The name of this experiment will be rust protection. Hello everyone, I am Kushaka Raj Gaurav and welcome back to my channel. Today we are going to focus on a key experiment in rust protection. We'll be using a method to safeguard iron from rusting and observe the results. In this experiment, we'll start by preparing an iron sample and applying a protective coating to it. Then we'll expose the coated iron to the conditions that typically cause rusting, such as moisture and oxygen. Our goal is to see how well the coating prevents rust formation compared to an untreated iron sample. First, the safety guidelines. Remember, while conducting the experiment, to wear protective gloves and eyewear, and make sure that you conduct the experiment on a safe underlay. This is the list of materials that you will need to conduct this experiment. You will need some copper wire, about 2 or 3 iron nails, some potassium hexacyanoferrite, a magnesium strip about 2 or 4, some sodium chloride, a phenol red, and a glass beaker. The glass beaker should hold up to 150 ml of liquid. And you also need a wooden splint or any plastic material that you can use to mix the compound. Now I'm going to tell you a step-by-step instruction. First, you will fill the glass beaker up with 25 ml of room temperature water. Then you would add 1 big spoon of NaCl or table salt. The next step is to add 1 big spoon of potassium hexacyanoferrite. After that, add 3 big spoons of phenol red into the jar. After that, mix the substance for about 30 seconds or more. Then, take a piece of copper wire and straighten it out, and wrap one end around one magnesium strip and wrap the other end around an iron nail that has a divider in between to separate two examples. Then get the petri dish, put the copper wire tied around the iron nail and magnesium strip in one end, and put a normal iron nail on the other end. Take a syringe and put about 10 ml of the liquid on both sides. After that, leave it for about 10 to 20 minutes and you will begin to see that the end where the copper wire is connecting the iron nail and magnesium strip to change the color of the liquid to pink, and on the other end where it is only the iron nail, you'll see the color changing and turning the color yellow to blue. Question: why is the nail covered in blue precipitate, and why does the solution in the second half of the petri dish turn red? The answer is that the nail is covered in blue precipitate because the Fe2 plus ions from the corroding iron react with potassium hexacyanoferrite, forming Prussian blue. The solution in the second half of the petri dish turns red because the phenol detects the OH negative ions from the corroding magnesium, changing the color to indicate their presence. Now, the explanation. Corrosion is slow and often not visible immediately, so we use potassium hexacyanoferrite and phenol red to visualize it. When iron Fe corrodes, it forms Fe2 plus ions, which bind with potassium hexacyanoferrite to create Prussian blue, which is seen as a blue precipitate. You can see the equation for corrosion over here. And when magnesium corrode, they also form a similar product, which you can see here. Phenol red changes the color from yellow to red in the presence of OH negative ions, indicating corrosion. However, in the presence of Prussian blue, this red color is not visible, which is why the solution in the second half of the petri dish turns red due to magnesium corrosion, but not in the first half with iron.